private IP addresses are for private networks, and private IP addresses cannot be used over the internet, which basically means if you want to download a web page from the internet, or you want to send a message to somebody on the internet using an instant messaging application, then that is not possible if you have a private IP address. So private IP addresses basically cannot be used over the internet, and private IP addresses are used for private networks, and private networks are called intranets. So who owns these private networks? Well, they can be owned by a person, an organization such as a school or a business. If it wants to have its own private network, then it can use private IP addresses. And for using private IP addresses, you do not have to purchase them from anyone. These do not have to be bought. Okay, so these are the private IP addresses that can be used on private networks. We have a class A private network, we can have a class B private network, and we can have a class C private network. So if ever you see an IP address such as this, right, because it's beginning with 10, then this is a class A network that is private, because anything, because 10 has been reserved for private class A networks. Anything beginning with 172.16 would also be a private network. So you have something like 20.44. If you come across an IP address like this is going to tell you that this is a private network, right? And it's a private class B network, right? So the first 16 bits are for the network, and the last 16 bits are the host ID or the host bits, right? Okay, and what about this IP address? 172.27.54.66. Is this a private IP address or not? Well, this is a private IP address, because what we've done here is, what I've mentioned here is the range starting from 172.16 to 172.31. If you see anything between 172.16 to 172.31, then that's a private IP address. So 27 is a private IP address. So this would be a private IP address, but this would not be a private IP address. This would be a public IP address. This is not a private IP address, because this number 32 is outside of this range between 16 and 31. So it should be between 16 and 31. So this is not a private IP address, but this is a private IP address. Okay, how about this? 192.168.0.1. This is a private IP address. Anything that begins with 192.168 is going to be a private IP address. Remember that. So if you see something like 192.168.254.36, because it's beginning with 192.168, it is a private IP address. So in this case, if this is the starting number, then this is going to be a private IP address, no matter what numbers we have here. So why would a company want a private network? Because it does not want anyone other than its employees to access the network. That way its confidential information stays secure. So a company may, for example, want to set up its local area network. It's going to have workstations, right? And it can also have a server, something like a web server, where the company can store its web pages on its hard disk, and these computers A, B, and C, this is where the employees can sit, and they can request web pages from this web server, which can be downloaded to their computers, and then they can view those web pages on some sort of a web browser. So this is an example of a local area network. An intranet, a privately owned local area network, which can be accessed by the company's employees only, right? And we can give some private IP addresses here, right? So let's say A has the private IP address 10.0.0.1, 10.0.0.2 would be B's IP address, 10.0.0.0.3 would be C's private IP address, and this web server can have the private IP address 10.0.0.4. So any one of these computers can send a request to this web server, can send a can request for a web page. That web page will be downloaded onto the computer, and now this person sitting on this computer will be able to watch that web page in a web browser. So that can be an example of a local area network which is going to be used only by the company's employees. And in this case, this intranet is not connected to any other network. It's not connected to the internet, it's not connected to any other network in the world. But sometimes a company may want its intranet to be connected to the internet. So for example, this computer A here might want to request a web page from this web server which is lying on the internet. Okay, so remember, this is our intranet, right? This is our intranet, and this is using private IP addresses. This is using private IP addresses. Okay, so in this case, A is going to create a request message, right, requesting for a web page, and that message will have the IP address of A as the sender's IP, right? So this is going to be the sender's IP, and IP address of the web server would be the destination IP. So once this request is prepared, this packet is now going to be transmitted, right, and it will travel all the way across to this router. Now this router, when it receives this packet, will take a look at the IP addresses, and it will see that the IP address used for A is a private IP address, because remember, the IP address of A was 10.0.0.1. When it sees that this is a private IP address, this router will drop the packet. Router drops the packet because of private IP, because of private IP address being used in the IP packet. So this router is going to drop that packet. So basically, this is not allowed. This intranet with its private IP addresses will not be able to send messages across to the internet, because it's using private IP addresses, So what is the solution to provide internet connectivity to the intranet? The solution is to use a NAT device. A NAT device is a network address translation device. So in our example, we are going to use a NAT device, and we're going to place it here, right, between the internet and the intranet. So between the internet and the intranet, we are going to place our NAT device. Now this NAT device is going to have two IP addresses, one on this side which is facing the intranet. On this side, it is going to have a private IP address 10.0.0.5, for example. Okay, and on this side, it's going to have a public IP address, something like 77.66.55.4, right? So on this side of the NAT device, which is facing the internet, it has a public IP. This is a public IP. This is not a private IP. So this IP is routable. It can be used over the internet. This IP, however, is a private IP, and it cannot be used on the internet. So the NAT device has two IPs. So now, if computer A wants to send a request to this web server, then it's going to create a request, and it's going to use its own IP of A as the sender's IP, and it's going to use the IP of the web server as the destination IP, and then it's going to transmit this packet. So computer A is then going to transmit this packet. It will travel all the way across to the NAT device. Once it reaches the NAT device, This NAT device examines the packet and it sees that A's IP address is a private IP, and the NAT device knows that the private IP cannot be forwarded onto the internet. So this NAT device is going to create an entry into its own database, its own memory, right? It's going to create an entry into its own memory. It's going to note down that IP address A was trying to send a request to this web server, so it's going to make that entry here in its memory, and then it's going to create a new packet, and this new packet would be the same request that was sent by A, but this time instead of using A's IP address, the NAT device is going to use its own public IP. So the public IP is what the NAT is going to use, and the destination it is going to once again have as the web server. So this new packet that has been created by the NAT device uses the public IP address of the NAT device as the sender computer, right? So now it's going to transmit this packet and it's going to travel all the way across to the web server. When the web server takes a look at the packet, it sees that the sender is the NAT device, and it sees that the destination is the web server itself. So the web server is going to process this request, and after processing this request, the web server is going to send the web page back. So who is the web server going to send this web page back to? The web server will create a packet through which it's going to send the web page. It may create a single packet or it may create many packets depending on the file size, right? But the sender's IP would be the IP of the web server, and the receiver's IP in this case is going to be the IP of NAT. The public IP of NAT, right, is what is going to be the destination. So this is going to be the destination IP. So this is going to be the destination IP. Now this packet will travel back through the internet all the way to this NAT device. When this NAT device receives this packet, it takes a look into its memory. It sees that this packet is basically meant for computer A. So the NAT device is going to create another packet. So this time the NAT device will create another packet. Let me just clear up some space here. Right, so this is where, so it's going to create another packet, the NAT device, and this would be the web page that it has just received, right? And it's going to have the IP address of the web server here as the sender, but here it's going to use the IP address of A. So the NAT device will change the destination IP to IP address of A, and then it is going to transmit this packet along this intranet, and it will finally reach computer station A. Okay, is this sort of a situation possible where we have two intranets? Let this be intranet 1, and let this be intranet 2. Is this situation possible where two different intranets can have workstations or computers with the same IP address? We can see that this intranet has 10.0.0.1 as an IP address, and this intranet also has a computer with 10.0.0.1 as an IP address. Is this possible? Yes, it is possible, because this IP address 10.0.0.1 stays within this network. It will not cross this NAT device. It will stay at the max. It can communicate to this NAT device, but on the internet this IP address cannot be seen. This IP address cannot be seen on the internet, so it is restricted to this area, right? So it's restricted to this area. Likewise, this 10.0.0.1 right here is restricted in this area, within this local area network, right? So there will not be a conflict between this IP address and this IP address. These are both not visible on the internet, they are only visible within their own local area networks. So this sort of a situation is possible. So what about our home network? See, in our home network we have a mobile phone, right? A mobile phone, we have a tablet, we may have a desktop, right, a PC, or we may have a laptop, right? So all of these belong to, for example, just one person, and we are all connected to this Wi-Fi router, which is in turn connected to this modem, right, broadband modem, which has been provided by the access ISP. So through this we are connected to our access ISP, and this access ISP is connected to the internet, and all of us are using, in this example, for example, our mobile phone has the IP address 192.168.0.1. Our tablet has the private IP address 192.168.0.2. Our PC has the private IP address 192.168.0.3. Our laptop has the private IP address 192.168.0.4, and they are all connected through wireless to the Wi-Fi router. Okay, so all connected through wireless to the Wi-Fi router, and then this Wi-Fi router is connected to the broadband modem, and this broadband modem is then connected to the ISP. So where is the NAT device? Because we are using private IPs here, right? So we are using private IPs here. So where is the NAT device? Somebody has to provide network address translation, because our private IPs cannot directly connect to the internet. We need the help of a NAT device. In this situation, this broadband modem, which is on one side connected to our home network and on the other side it is connected to our access ISP, is the NAT device. So this is going to have two IPs, one on this side, which is most likely one on this side, right? So one on this side, with this might most likely be 192.168.0.5, and the other one on this side. On this side it is most likely going to have a public IP, for example 77.66.33.4, right? So this broadband modem is basically our NAT device. I'm sorry it looks very messed up, but I hope you understand the concept. At our homes, for our private network, where we have our PC, laptop, mobile, tablet, everything connected to the internet, we are using private IP addresses, and the modem that has been provided by the ISP is basically acting as the NAT device. Now this NAT device sometimes is also called a proxy server, because it is doing our job for us. This NAT device is sometimes also called a proxy server because it is contacting the internet and trying to get information that somebody here on this private network wanted, right? So maybe through this tablet we wanted to access a website, and because we can't directly access this website because of the private IP, the NAT device is going to help us get that web page from the internet. That is why we say that the NAT device is behaving like a proxy server. It is doing something on our behalf. That's why it's called a proxy server also. Okay, in this network, this is a typical home network. Only one person, only a single individual can have so many things connected to the internet. He can have a tablet, he can have a laptop, a personal computer, a mobile phone, all of these belonging to just one person connected to the internet at the same time. Just imagine one person using 4 public IP addresses. How much of a loss would that be? Remember, we only have 4 billion public IP addresses approximately. So in this situation, our broadband modem, if it behaves as a NAT device, what we are doing is we are using private IPs. So instead of using public IPs, we are using private IPs for this, some private IP for this, some private IP for this. So instead of using public IPs, now we have used private IPs. And just imagine, by using private IPs here, we have saved so many public IPs. So this is an important step towards saving public IPs. I hope you understand this. Just one public IP being used by the NAT device to represent all of these private IPs in this network. So just one public IP needed. So we have saved a lot of private IPs. We have saved a lot of public IPs doing this.